All right, so bisectors of triangles is our topic for today. And you have a foldable in front of you. And we talked about this video yesterday. Okay, so now you will need to work on, you'll have some work over the weekend to do. There are 2 videos from yesterday on my website in the geometry for yesterday's assignments. Watch those and do the GeoGebra activity that's there and show me screenshots of your activities when you're done. Okay, you can take a picture of them with your phone. If you do it on the computer, take a picture with your phone. Okay, there were 2 on the day before that as well on Wednesday. And so take a screenshot of those and show me, and you can get those points. Okay, so during these activities, I hope that you learned a lot about the things that we're going to talk about now, and you'll just be, oh yeah, I get that. We're good. Okay, because I think learning by doing is better than having someone come up and talk about it. Okay, so the first one that we made, the first point of concurrency that we made was called the circumcenter of a triangle. That circumcenter of a triangle is formed by taking the perpendicular bisectors of the sides of the triangle and finding out where they meet. So when 3 or more lines or rays or segments intersect at the same point, they're called concurrent. Before, we've just talked about 2 lines intersecting at a point. But when it's 3 or more, they're called concurrent. And the point of intersection of those lines, rays, or segments is called the point of concurrency. Lots of vocab this chapter. So in a triangle, the 3 perpendicular bisectors are concurrent. Bisected this side with a perpendicular bisector. Same thing with this one and this one. They meet, and their point of concurrency is called the circumcenter. Okay. There's a special property about that circumcenter. The circumcenter is equidistant from the vertices of the triangle. So when we take the perpendicular bisectors of a triangle and find their point of concurrency, that's the circumcenter. That circumcenter is equidistant from the vertices. Bisect the sides is equal distance from the angles, points. Yes. So it's up to you, okay? I think it's helpful to see it. So if segment PD, segment PE, and segment PF are perpendicular bisectors of triangle ABC, then PA will be congruent to PB, will be congruent to PC. It'll be equal distance to the vertices. So one more time. Take the perpendicular bisectors of a triangle. Their point of concurrency is the circumcenter. The circumcenter is equidistant from the vertices. Okay? Turn and teach. All right, so here we go. Here's an example of how this can be applied in real life. Omaha Zoo is doing a major expansion. I don't remember if it was 56 million or something crazy that I read about the other day, which means that prices are going up. But they're bringing in an African grasslands area. This, I think a lot of it comes live this summer. Yep. They have a Future Elephant Amphitheater that's coming into play. They saved some elephants from being culled from the herd because they were the wildlife management area that they were in was overpopulated, so they were going to kill the elephants. So they're going to bring those in. There's also going to be a giraffe herd room. The giraffe herd room's there, but there's going to be a giraffe encounter and so forth. Okay? So when the people at the zoo decide where to put a new beverage cart, they may say, guess what? We want this to be equal distances or equidistant from the Skyfari Landing and the elephant family quarters and the elephant amphitheater, so we can serve our customers. Okay? So you think, okay, well, it needs to be right in the middle. Well, what is equal distances from those 3 points? What's the name of that point called? The circumcenter. Okay? The circumcenter is equidistant from the 3 vertices of the triangle. How do we find the circumcenter? How do we find it? We find the perpendicular bisectors. Okay? So what I did was I took this map and I took it to the GeoGebra and I uploaded it, and then I found the perpendicular bisectors, and then I found the point of concurrency, the circumcenter, and that's where that beverage cart would need to be. Okay, so it is in the place that is equal distances from the Skyfari Landing, the elephant family headquarters, and the elephant amphitheater. So it would be difficult to do it without compass and straight edge, right? But I can ask you to eyeball it or give you some, on Monday I'll give you rulers, and I'll ask you to maybe do paper folding or use, I don't think we'll get the compasses out, but we'll at least be able to say, okay, this is my segment, here's the bisector that's perpendicular to it, here's my next segment, this is the perpendicular bisector to it, and here's my third one, here's the perpendicular bisector, and get a good estimate of where it would be. Okay? That's what the zoo's going to look like, yes. I made up the part about the beverage cart. I don't know where they would want to put the next one, but it's a real-life application. Okay? City of Papillion is getting ready to put together a new entertainment or rec center of some sort. I think it's going to be where the soccer complex is because they've got land there and there's a park there. But they could decide as city planners, hey, we want it to be equal distances from the 3 middle schools because we want it to be as close as possible to all of our junior high kids who need to bike there. Okay? So that would be another application of it. Of course, there's zoning laws and things that you wouldn't want it in the middle of a residential area. It needs to be in a business area and so on. But that's another example of how that is used in real life. Okay? And if we had the 3rd high school and knew where the 3rd high school was going to be, we could build it equidistant from the 3 high schools. Eventually. Eventually. Yeah, it opens this fall. I don't remember the name of it. Okay, so here's how we do this when we have a coordinate plane. Okay, so you've got an example just like this in the bottom. Okay, and we're asked to find the coordinates of the circumcenter of triangle DEF, and I've got it all plotted for you. Okay, so here's D, here's E, here's F. If I want the circumcenter, how do I find it? Bisectors, not only the bisectors, but the perpendicular bisectors. Okay, and you can kind of eyeball it. And the reason we can eyeball it is we're nice to you. Okay, does anybody want to find the perpendicular bisector of this diagonal line? No. So we're going to give you some, I don't blame you, I wouldn't lie either. I'd say absolutely not. We're going to give you horizontal and vertical lines. Okay? Sure. Okay. Well, we don't even need to use a yardstick. Okay? Because what's the midpoint between E and D? What's the midpoint? Yeah, 2, 4. Okay? Very good. 2, 4. And we can count it in. Okay? Let's not lose focus. We can count it in, or we can use our midpoint formula. 6 and negative 2 is 4, divided by 2 is 2. 4 and 4 is 8, divided by 2 is 4. There's our midpoint. Okay. Let's find the midpoint of EF. What's it going to be? Negative 2, 1. Then you'd have to be at the halfway mark. Yep, or the third or whatever. I don't think so. I think they're giving you nice numbers. Okay, so we found midpoints. Okay, that gives us the bisector. How do we find the perpendiculars? What's perpendicular to a vertical line? A horizontal line. Okay, so here's my horizontal line. What's perpendicular to a horizontal line? A vertical line. And just because the 3 of them will be concurrent doesn't mean we can't stop with 2, right? So here is our point of concurrency. What's its name? What's the name of that point? The circumcenter. We found it. Okay? So you're going to have problems just like that. Okay? All right. Let's talk about our other side. Okay? So point of concurrency for perpendicular bisectors was the circumcenter. And there it is. Sometimes it's inside the triangle, sometimes it's outside the triangle, sometimes it's on the triangle. Okay? We also did an activity yesterday that dealt with the angle bisectors. Okay? The 3 angle bisectors of a triangle are also concurrent. And their point of concurrency is called the incenter. The incenter of a triangle, no matter what we did yesterday, we couldn't make that thing come outside of the triangle, could we? No matter how we move those vertices. So the incenter of a triangle is always inside the triangle. And it's formed by finding the angle bisectors. Bisect the angles. You find the incenter. Okay. Are you ready for the next slide? Not quite. Okay. The Incenter Theorem. Sure, I'm sorry. Just trying to keep us moving so we have some time to work. So the incenter theorem tells us a special property about incenters. It says that the incenter of a triangle is equidistant from the sides of the triangle. Perpendicular bisectors equidistant from the vertices. Incenter equidistant from the sides. Bisect the angles. You're equidistant from the sides. Find the perpendicular bisector of the sides. You're equidistant from the vertices of the angles. So if segment AP and segment BP and segment CP are angle bisectors of this triangle, then the distance between PD is equal to the distance between P and E is equal to the distance between P and F. And that distance is always the shortest distance to that line. The distance between a line and a point is the perpendicular distance to that line or that segment. Okay. Everybody ready? All right, here's how we can apply it. We have to find the distance between N and D. So we want to know how far is this distance. And we are told that the distance between N and E is 6x plus 1, and N and F is 4x plus 15. How are we going to find the distance between N and D? Megan? We would make them equal to each other. And why would we make them equal to each other? Those are those segments, right, that are formed from the incenter to the sides, right? The incenter is equal distance from those sides. So these distances have to be set equal to each other. Very good. Okay. Now it's a matter of solving, right? So Liam, what are we going to do to get the x by itself, or solve for x? Subtract what? Take the 4x to the other side. We get 2x. And Faith, what are we going to do to get Julie? What are we going to do to get the numbers but to the side? Yep, subtract 1. Don't do it the other way around for some reason. I don't know why. So x is 7, right? Are we done? No. So, Michael, what are we going to do with this 7? You don't know. You have a guess, though. Plug it in where? Does it matter? No, because they're all equal, aren't they? Okay. So, do you prefer to plug it into 6x plus 1 or 4x plus 15? 4x plus 15. 4 times 7 plus 15 gives me 28 plus 15, which is how much? 43. So this one's 43, this side is 43, and this segment's 43. Okay? Answer's 43. Part B says, can the distance between N and B be equal to 40? What do you think, Skylar? Why not? You're right. You're exactly right. Why is it not reasonable? Okay, what kind of a triangle is this triangle up here? We have a 43 here. We're thinking this could potentially be 40, and you say that isn't even reasonable at all. What kind of triangle is that? A right triangle. And 40 would be the, what part of that right triangle? Got a special name? Leg, leg. No. Leg. It's a right triangle. What's that special side on a right triangle? Hypotenuse. This is the hypotenuse. Is it possible for the hypotenuse to be smaller than a leg? No, hypotenuse has to be the largest side of a triangle, doesn't a right triangle, doesn't it? Okay, so it's not possible because 43 is bigger than 40, and the hypotenuse has to be the largest side. Okay. One more quick one. Okay. Now we've got a school who is trying to put in a swing set. So they've got a fenced-in area that's a scalene triangle. None of the sides are equal. And they want to put the swing set so that it's equal distances from the fence, maybe for mowing purposes or what have you. They want it to be equidistant from the fences. Are we going to find the circumcenter or the incenter? Hearing people whisper it. Incenter. Why incenter? Yeah, it's the equal distances from the sides. The circumcenter is equidistant from the vertices, and they want it to be equal distances from the fences, the sides. Okay? Same thing can happen if you're a landscape architect. If you've got a triangular path, maybe you have a sidewalk, and you don't want the sprinkler to hit the sidewalk, right? Anybody ever like sprinklers hitting sidewalks? Doesn't do any good, right? You're watering concrete, it's not going to grow, and it makes people mad when they get hit by the sprinkler. So you can find the incenter and then make that head only touch or only have a radius as large as it is from the incenter to the side of the sidewalk. Okay? Then you would have to plant this with something that doesn't require watering. So you'll often see that. You'll see a circular grassy area, and then the corners will have something else. That's what they're doing. Landscape design. Uses for these things. Okay? Assignment should be on your phone. If you're lucky enough to have an Apple Watch, it's on your watch. It's also here, and it's posted on my website. Okay? Don't forget. Some of you owe me some screenshots of yesterday's stuff. Did you get it to me today?